Hi everyone. So in this video we'll go over the basics of GROQ, and in the other videos in this series we'll explore projections, global functions, and some advanced queries before wrapping up. There was one video I created in the recipe project where I gave brief explanation about GROQ. It was not a detailed one, as we were just simply querying the recipes that we created, and so I thought of coming up with this series. So GROQ is a query language that runs on JSON objects. We don't need JSON objects to be in separate collections like we have in MongoDB. So for this series, what I have done is I have set up a project, starter project from the Sanity init command. We get few project options. So I have set up the movie project, and in this it's a simple project where we have a movie schema, person schema, and screening I'm not using right now. And in the movie I have added some dummy data. I'll quickly go over the person schema first. So in the person schema we have name, slug, and image. That's it. And in the movie we have the title, slug. Now this is a portable text. This is a date. This is a number type. Again, popularity is again number. We have an image. We have cast member. So this is basically referencing to the person schema. And crew I did not add. I think it's not required as of now. So what we'll be doing is we will go over a few GROQ queries. In this video we'll go over some basics, and then in the coming up videos we will go over projections and some advanced stuff. So just to start with, almost maybe most of the queries that we see, it starts with a star. I'll just zoom it a little. Normally starts with a star. So star, if we run this query with just a star, nothing else, it will return all the documents from the dataset which the user has access to. So if I just run this, okay, so I just ran the star query, which actually dumped the whole dataset, but I ran it because our dataset is very small. It has hardly 40, I think hardly 40 JSON objects, but you shouldn't do it if you know if there is if you have a large dataset, because it's of no use anyhow. We will always be filtering out the data that we need. So how we filter is the next step. So what we do is, I'll just zoom it a little. So in order to filter it, what we do is the data flows from left to right. So with star we are getting the whole data set. Now in order to filter, the data is passed to the filter. Now in the filter we will write what exactly is the data that we need. So let's say we want the data only from the movie schema. So in order to do that, we have to type equals. We have to make sure that it's double equals, because we are like comparing, we are not assigning, and it has to be movie. So the star will give us the whole data set, and that data set will be passed to this filter. And once we run this, we'll get you can see we have only 5 items, and all the data set, all the JSON objects are of type movie. Let's say that we don't want we want all the every data set from every schema, but not of type movie. So I'll just keep a copy of all the, let's say we want all the data from all the schemas but not from movie. So what we can do is, it's like the JavaScript style. We can just give an exclamation mark before the condition, and now if we run, So we'll get all the data sets from we'll get all the JSON objects from all the schemas other than the movie. Next is we want the results from the movie as well as person. So let's say that we have multiple schemas and we are looking for data only from any of the two. So one way to do it is that this is type of movie, and then we can give an OR operator. This is how exactly we have in JavaScript, and then we can type equals, we have only two in our project, one is movie and one is person. So this will you can see this will query and return the data from either movie or from person. It's an OR operator. So now over here you can see we have person and we also have movie, because the data we have the data. So over here you can see that data is flowing from left to right. We had all the data returned from star, and then it got filtered. But now there is a better way to write this using the in operator. So I'll just copy it and I'll comment it. Yeah, so the other way to write it is like this. I'll just type in using the in operator, and we can give movie and person. Yeah, so both are the same thing. We have person as well as we'll have movie. Yeah, we have the movie. Fine. So because we have an OR operator, we also have an AND operator like we do in JavaScript. So we'll write something different. We'll just see we have a movie, and over here we have one field as popularity. So let's write some AND condition. So what we want to do is we want to query type movie, and we want to see all the movies where the popularity is greater than, let's say, 50. So if I run this, so you can see we have 3 items returned. One, this is movie with popularity 80, this one has 60, and this one has 100. Okay, so over here you can see we got 80, 60, 100, but nothing is in order. So let's see what we can do. Yeah, so as I said, it's all the data is flowing from left to right. So this gave us all the data. Now this has filtered and given us 3 results. Now what we want is we want to order, we want to sort it, maybe in a descending order or ascending order anyway. So what we can do is, once the filter is after this is the filter in the square brackets, after that we have to put a pipe. It's called pipe, and it's very similar to Unix style, where we run commands and we pipe it to the other commands. We just pass the data to the other commands, so it is similar to that. So over here what we'll do is we will pass whatever results we'll get. Like over here we are getting, at this point we have 3 results, so we are putting a pipe, and then we are using because we want the result to be sorted or ordered according to popularity. So we'll just pipe it to order popularity. Now when we run it, so we can see that the first result has popularity as 60, then 80, and then 100, because by default, if you don't give any order, ascending or descending, it's default ascending. If we want it to be in descending order, we can do something like this, popularity descending. And yeah, over here you can see we have popularity 100, 80 and 60. In the order function we can actually pass more attributes, whatever we like. Let's say the release date, and this will be ascending and popularity is descending, and if you want release date to be descending as well, so we can do something like this. So it's up to you. So you can try it on your own. So let's say that we want the title of all the movies that we have in our dataset. So in order to get that, we'll have to first query all the movies. So type equals movie. Now the thing is, over here if I just run it, you can see we have all the JSON objects for every movie, but what I want is just the title, nothing else. So what we can do is, one way to do it is just type title, and if we just run it, so you can see we are getting an array with the title of the movies. In the coming up video, we'll see when we will start learning projections, so we'll see how we can select more than one attribute. Over here I've just selected one title. Now the other thing that I want to tell you is about indexing. Yeah, so indexing. So let's say that we'll take the previous example. So over here, yeah, so over here you can see we have the list of titles. Now let's say we want only the first one. So what we can do is, now this will not work if we do like this, so it's not going to work. The thing is, we want the first the title of first object. So what we can do is we can index it here. So this is the whole complete data set. This is our filter, and from the filter we are pulling the first item, because it's going to be an array, and then from this one, from the first item, we are taking the title. So over here you can see we got the marsh. So this is called indexing. It's not necessary that we can do it on the whole data set as well. So let's say underscore type, let's go to person now. Yeah, so we have 18 items. So let's say I want the first one, it's Guy Peer. So if I want the first one, you can see we have the first one. It's like any other array, because let's say I want the third indices, so over here we can get it. So now if I want from the end also, we can get it. Let's say that I'll just run it. Let's say the last item, if we see, it's Matt Damon. So if I want the last item, so all I have to do is -1. It's very similar to Python style, where we can give the indices in negative order, or in JavaScript we normally have to do slice. So over here we can give -1. So we have this Matt Damon. So this is indexing. There is another concept, it's called slicing. Yeah, so in slicing what we do is we take a slice out of the whole result set. So it will not be just one item, it can be maybe 5 items, 10 items, it will be a range of items. I'll just quickly show you. I will again take the person schema, and yeah, so in this let's say that I want the first 3 items from this result. So what we do is we do it like this, 0, because we want the first 3, 2 dots and then 2. Now if I run this, you can see we have 3 items, 0, 1, 2, and this is called inclusive slice, because we are we have included the 0 and two index, both are included. And there is a way to and we can also get there is a non-inclusive as well. I'll just show you. Let's say we'll go back to type person, and let's say I don't want the last index that I mentioned, I don't want that in the result, so it will be 3 dots with 3. So this will give me the first 3 results. So over here you can see when we had 2 dots, so 0, 1 and 2, all the indices were included. Now when we have 3 dots, the last index which is mentioned, it's not included. So this one is called non-inclusive slice. So because this part of this first video is for the basics, so I will quickly tell you about 2 more operators. One is the sign of @ this is the @ but this is called this. This is not called @ this is called this. It's an operator, but it does not take any operand. So over here @ this operator, which is called this, it refers to the current scope. I'll give you a small example. So let's say that we want okay, I'll quickly write one small example. We'll again take person schema, and yeah, so type person, and let's say that I I order it, because now if I'll just quickly run it. If I just run this, so we have person and it has an attribute name. So what I'll do is I'll just order the results according to name. Okay, so this looks fine. Like we have A in the beginning, the first one, and the last one is with W. It looks sorted. Now we'll do one thing. Now I don't want the whole JSON objects to be sorted. I just want the name. I just want a list of name, and I want them to be sorted. So let's say in order to get the list of names, so what I'll do is person, okay, and if we just type name, yeah, so over here you can see we have type name, type person, and we are just interested in the name of all the person in the person schema. So here we have the list of names. Now next what I want is I want to sort it. I want to sort this because it's currently not sorted. So if I try the same thing that I tried above, say order name, so you can see nothing happens. Nothing happens because the data flows from left to right. So after filtering, we have all the data from the person schema, but we are fetching only the name, so it returned an array of just strings, an array of strings. Now when we pipe it to the order function, we are saying we want to order it according to name, but it's actually an array of strings. It's not an array of JSON objects, so name is nothing over here, it's just string. So one way so how do we order this? So as I just said, we can make use of this, that is the @ because this refers to the current scope. So in this scope we have array is in this scope. So if we pass the whole array, that is if we pass order in this inside order function, so we are actually passing the array into the order function. Now if we run this, so we can see our array is sorted. And similarly, if we want it in a decreasing order, we can do it. And if we want to slice, inclusive slice, we can do it. So you can see there is a lot of flexibility here, a lot of options for us to do. So there is one last operator I want to talk about before I wrap up this video, and that is the caret operator. It is called parent. So it is again similar to the AND operator. It does not take any operands, but this refers the data or the caret basically returns the root value of the parent scope. Like @ was returning the value of the current scope, but caret will return the value of the parent scope. Now to run an example, I have few ideas, but I think we'll first complete projections, which is the next video, and then I'll come back to give an example about the parent scope. See you in the next video. Thank you.